Alrighty, we're gonna get started, and thanks for joining today. This is all about Java, by the way. How many people are actually Java developer here? Very nice. Okay. If not, door over there. Okay, just kidding. All right. So we're gonna talk a little bit about performance tuning about Java application on Kubernetes and then many practical tips. And my name is Daniel. I'm from Red Hat/IBM. I'm longtime DevRel and developer advocate and CNCF ambassador and Java champion. And here's Kevin and I. We are reading some new tech, the technical advisory group for developer experience. So if you have any interesting contribution back to CNCF around developer experience, please let us know. We are more than happy to chat. And here's my colleague, Ryan.
Hi, I'm Ryan Jarvinen. I'm also Red Hat previously, currently at IBM. I've been going to KubeCon for quite a while. I'm wearing my 10-year-old KubeCon 1 shirt. Excited to be here and share our experiences with you.
That's nice. By the way, I'm from Boston. My flight was delayed 5 hours on Sunday. Thanks to America, by the way. Anyway, so I'm still a little bit like a Taiwanese. And then if you feel something uncomfortable voice from me, and then please understand that. Okay, so before we jump into the actual performance tuning part, so everybody knows Java will be quite slow for the decades because Java was born 30 years today. And at the time, Java was great for enterprise application with JVM, not cloud. And for your business application, enterprise application, a little bit heavyweight, nobody actually don't care. It takes more than 1 minute to start up, like a JBoss or WebLogic and IBM WAS. It's a pretty heavyweight. Putting a lot of business application services, we can say monolithic application at a time. And the things change that. Everybody moving forward to microservices like a Spring Boot, Quarkus, and Micronaut, and any other Spring, like a Java framework. And then people try to refactoring all monolithic application to microservices. And now you have a cloud. And still your Java application may be quite slow to start up and response time. And then eating a lot of resources and memory footprint. And then when you packaging your application container, and then, there's something problem. For example, Ryan, we'll talk about that a little bit later. So when you deploy Java on container and container startup, and inside the container application also startup on JVM, it takes time, like a couple of seconds, maybe depends on how big your application is. Sometimes it takes more than 10 seconds. And then Kubernetes just kill the pod because there's no response at all. So also when you scale Java application compared to pretty lightweight applications such as JavaScript, .NET, Golang, and Python, and so on, and it bigger application, which means a bigger container size, and is consume more network latency or network kind of stuff, and storage as well. It's all about the money. So this is a potential issue. That's why a lot of DevOps engineers, your common enemy, or platform engineers, they decide, hey, we need to go to something other thing, like a JavaScript, Golang, or Python. But you know what? There are more than 12 million Java developers around the world, including me, including you all guys. So we don't want you guys to lose job today. So how do you overcome this challenge for that?
Yeah, so this slide shows the blue line here. This reminds me of the blue line here is the typical service level agreement that Kubernetes is going to expect when starting up a typical kind of stateless app, maybe a non-Java, a typical more modern application. And the red line is showing a classic kind of monolith architected JVM app that's going to take a little bit longer to warm up. It's going to need to do class loading. It's going to need to do some JIT optimizations and whatnot. And eventually it'll usually have some higher throughput or a higher performance than the blue line here, but only after a certain amount of time, right? So we need to wait on Java and configure Kubernetes to accommodate or speed up our Java, right? So this tips we'll give you here should give you faster startup, cold and warm, help you reduce your memory footprint, and lead to smaller and leaner containers. And with a newer JVM, hopefully you have Kubernetes-native Java all supported in here. So let's get to the tool chain overview.
Yeah, sure. So by the way, that like a JVM scaling issue. So one of the, it's a Vodafone Greece is one of the like a popular company in Europe. They actually same problem with the Spring Boot. So deploy Spring Boot on Kubernetes, and then that Spring Boot takes some time. Hey, give me the time to start up and warm up. But Kubernetes fantastic feature like a liveness check or readiness. Oh, you got some problem? What's wrong with your Spring Boot? I'm just kill you. It happened over and over again until to death. And they actually, how do we fix the problem? And they actually changed the Java framework to Kubernetes-native Java framework. And I'm going to show that a little bit later, the demo. So what kind of tool, what kind of open source project software you're going to actually pick it up and use that? If you go to a CNCF landscape today, there are thousands of different softwares right now. It's really hard to pick it up right one for your performance in Java tuning. So for example, the zip is like a Google invented that thing. It's you don't need to like some Docker file or command line kind of stuff, but you can still build your application as a container. It's a more small and lean container. And the GraalVM is invented by Oracle. It's create the executable file. Like when you go to Windows operating system, you can find like a exe extended file, which is you can execute that file without any runtime. That is exactly the same. So Java fundamentally uses JVM as a runtime, but you don't need to use JVM anymore. But you still want to run Java application and really fast, and then startup time and low memory footprint. And then there are also like a CDS faster JVM startup and a CRaC for snapshot for JVM. And also like some another Java project from OpenJDK, the Raiden, is without GraalVM, but still really fast startup time. We're going to go through a little bit detail in the next kind of stuff. And the Quarkus, and it's more like a Kubernetes-native Java, was born 6.5 years ago. It was designed for all new Kubernetes-native technology and also developer productivity. It was always integrate with the like a GraalVM stuff, native compilation, and like reactive programming and Kubernetes integration, but also with the LangChain4j for AI stuff. Another quick question: how many people actually heard about the Quarkus before? Okay, very nice. I'm so happy for that. All right, there we go. And so. You want to talk about that, or
Yeah, let's see.
You. Okay. Anyway, so yeah, so Jeep is using Jeep, and you can actually use the Maven and Gradle. So Java developer already familiar with the packaging tool with the Maven or Gradle. Some people are actually still familiar with the Gradle, Maven rather than Gradle. And then when you build container image, you probably use like a Podman or a Docker CRI, which is another tools. And then developer actually hate it. So I want to do something new, but I don't want to use a new tool. I just need to keep my own tool, like a 12 tool, not 13 tools. So that's Gradle Maven provides some command line to build container image with the Docker daemon requires. It's a pretty simple, no extra installation. And GraalVM, as I mentioned earlier, when you create the executable file, it depends on your underneath operating system. When you build native executable file on your macOS, for example, it running by default on macOS, not Linux, not Windows. You can actually set up platform type like a Linux x86 or something like that, and that executable file only running on that platform type, not your local machine. So sometimes the GraalVM and the native executable file really hard to troubleshoot, like a heap dump, or you usually do with the Java. When you got some problem, you got some know how to troubleshooting your application, like a Java application, but you probably can't do that. And it also takes some time, not a couple of seconds to build application. And Quarkus, again, like a 6.5 years old, was born, invented by Red Hat, of course, and then Red Hat donated to Common House, which is a non-commercial organization and more maintain a lot of Java projects like Hibernate and skmain, JReleaser, and among others, including Quarkus. So here's just some interesting number here. So Quarkus gives some great performance thing, not only like a Kubernetes, like a container environment, but also you can run like a virtual machine, bare metal, and any kind of application like a traditional microservices and serverless and reactive application, even AI, like a generative AI or agentic AI application. Here, response time, and then you combine this performance data in the Quarkus.io as well. And then moving to like a CDS.
Okay, CDS is going to help you preload class metadata into a shared archive. It's going to help the JVM start up faster by skipping your class parsing and some of the load up. This works with OpenJDK and with containerized workloads. I have an example here of how you roll this or how you'd activate this. You could use the archive class at exit parameter, and then you memory map the preprocessed data back into the JVM with this other flag here. Next up, we have coordinated restore at checkpoint. This one's a little bit experimental, but important to cover, I think. This is going to help snapshot a JVM state to disk, give you near instant startup, and it's going to preserve a lot of the JIT optimizations, so they're restored in a warm state, right? The app's already running at peak speed. This is great for serverless and Kubernetes scaling, but requires a supported JDK to implement.
So for example, if you have experience like a serverless or Amazon Lambda, and then you probably have a multi-choices how to start up to overcome cold start time. Like a cold start is a couple seconds to start up. It takes some time. Sometimes it's really bother your customer. And then the Lambda provides like a snap start, new methodology and some kind of new feature, which is basically using this CRaC. So it's a really fast start time without like a GraalVM as well. So you can still using JVM to run your Java application on Amazon Lambda, but it takes like 100 milliseconds to start up using the CRaC, like based on snapshot. You don't need to full scanning your Java on the virtual machine stuff, but you can go back to some specific point to get some snapshot point, just a really fast startup time.
So here's a quick example of what that would look like. First, you'd create that checkpoint and snapshot a running JVM to disk. And this is going to save its entire memory state to disk. Then you go and restore it. I don't have examples here, but you could look up the parameters there.
All right. It was really boring to keep looking at the slide. So let's go into the demo. So it's like the primary goal of this demo. You already saw a bunch of the open source software. It separates open source, like a zip and CRaC and part of the OpenJDK, of course, and GraalVM, among others. And then, so how do you do that to use a multi-open source project on your Java project? You can find the relevant dependency library on your Maven project and put in some compilation your XML, POM XML, or graduate modules. And then try to find which version I'm going to use based on compatible my Java version kind of thing. And so this is like a known way how to integrate a multi-open source project into your Java project. So I'm going to use Quarkus State, and the Quarkus has natively integrate this all kind of stuff by default. You can actually selectively add or remove that. So pretty much easier, like a framework level. So we have limited time. I don't want to go every single detail. Okay. So basically, if you don't have any experience with Quarkus, you can go to Quarkus.io, which is like our official community page, like a Spring.io. And there I go to like a browser, and you will see like more than 844 extension, which is like an ecosystem. And there are more than 1,000 actually on the Quarkus universe. And then you can find many category integration, data, web, and security, and reactive application, observability for production, workload, and authentication, and OpenAI Cloud, and among others, even Kubernetes here, and AI as well. And then you can go to start coding, which is like a initializer, code generation. So go to the code generation, and you can change global artifact ID in the packaging tool, like a Gradle or Gradle Kotlin. And Java version, we're gonna add like 25, but it doesn't mean you cannot use 25 or 26. You can use technically, but we put under some specific number version here is LTS version only. But you can still use any Java version after Java 17. You're not using Java 11, Java 8. Please don't tell me you're still using Java 8. Please don't. Yeah. You are like a dinosaur. Unfortunately, that's true. Yeah. And then, but also, even if you use some experience with Java, Spring, or other thing, there are thousands of ecosystems. And then first your challenge is, so which library I have to choose? It's a big choice. And luckily, Quarkus actually gives some pattern, like a REST services or REST and databases or a reactive application with like a Kafka or command line web application and AI application. So I created like a REST API application here and automatically generate my file. And then you can see that under the like a source directory, and it automatically like a Docker file, like for Docker JVM and regular CJAR and native micro image. So Quarkus fundamentally overrode the class loader, which make Quarkus make it faster. Already understand where the library dependency exists, and also Quarkus shipped all necessary job from runtime to build time. For example, the Ryan already mentioned about what happening when you run Java application on JVM. There are like a parsing descriptor, enable, disable some of the like features, and then annotation, scanning, among others happening in runtime. That's the fundamental Java mechanism. But Quarkus took that off and then put into build time. That's Quarkus really fast when you run application. And then, but we're gonna not using Docker file here because we're gonna use zip. And first thing is Quarkus like a dev mode, which is like a development mode running your Quarkus application on the runtime. And then by the way, I'm using here Java 21. I can use in Java 25, but I'm gonna deploy this application to Kubernetes, which currently provide the fundamental image is 21. But if I change it 25, and then you can see that the IntelliJ automatically save my file underneath the Java runtime, automatically recompile, restart. So this is really cool. I don't need to do that manually. And then when I go to welcome page, and then you can see hello, which is one of the endpoint, and hello from KubeCon North America 2025. And the other one is go to hello and then welcome Dan and Ryan at the Cloud Native Experience track kind of stuff. Just too simple, like a hello world style endpoint. And I'm gonna go back to 21 again for deploy the Kubernetes in Synapse. And back to my application here. So just endpoint and very simple. So just like a simple sample application. And in the meantime, my Quarkus runtime already compiled. And then if I go to reload, and then my application totally working. So now I'm gonna try to packaging my application, just looking at how big my application is, and then memory footprint and so on my local machine. And to do that, you can use Quarkus CLI, you can use a Maven command line. This is a Maven project. So I'm gonna do like a Maven packaging stuff here, and then go to test automatically. Oops, I got a submitter. Oops. Yeah. Is it Java version here? At 21. I don't know. Okay.
Change the test.
I don't know. Okay, let me try to turn new terminal. That's the beauty of a live demo, isn't it?
Yeah.
I don't show recording kind of stuff. Okay, but I forgot to play the demo guy. Okay. Yeah. Okay, let me try to build again. Okay, now build success. And then try to run Java runtime. And before that, here's my activity monitor on my Mac OS. And try to find some Java. I'm already running one Java, 190, somewhere like another Java application. Okay, when I run it, and now you can see that here is a 0.260 seconds to start up. It's still fast, like now a couple seconds on JVM. And then open another terminal and then try to access endpoint. There we go. Hello. And then a couple more time, just give it some workload. And now he see that previously 107 and now 112. It's like 100 memory per frame kind of thing. And then if I just stop and then try to build like a native compilation, which is all Quarkus project automatically included that native profile when you go to, oh God. Okay, let me try to using Quarkus.
You change the resource, the text in the test itself.
Here? Which resource?
No test flag.
Huh?
In your test. It's
On your test?
string.
This one? I don't think, yeah, it's still the same. Ah, right.
Cloud native track.
Yeah.
Yeah.
This is one of the beauty of the Quarkus continuous testing stuff. Yeah. Whatever I change, I forgot something. Okay. Automatically. Okay. And back to the Quarkus command line. Okay, here is go. Maven command -d native, because when you go to POM XML and you will see the profile almost the bottom here, the native profile automatically compile native executable kind of thing. So when you build native executable file, it actually took a lot of memory rather than CPU. So we will see some number here. Here we go. So here's memory is a 2.69 giga memory. So which means you probably don't have fancy edgy laptop or desktop for your company, which means that you probably cannot build native compilation based on your application. So in reality, you just ask your like a fantastic platform engineer team, hey, I'm just to push the code and you're gonna run fantastic CI/CD pipeline like Argo CD, Kevin, right? And then that is we do some agentic AI automatic build native compilation and so on. However, as developer, you also need to verify the native compilation works or not on your local machine. So when I go to like a target directory, you will see one executable file here with 45 megabytes. It's a small thing. And I'm going to just run without Java command line because the native executable file, I don't need to JVM anymore. Just run under the target directory and runner. And then when I run it, and you will see here 28 milliseconds, which is exactly 10 times faster than like a JVM. If I'm right for the math, just let me know if I'm wrong. And go to activity monitor and try to find out that process here is 8.7. It's almost 12 times less than memory per frame. And I go back to terminal and then try to run the invoke REST API a couple more times to give it some workload. And then now it's just 2 megabytes slightly increase. It's really fast. And then I'm gonna just stop thing just to show. And then in the meantime, I just keep using the Graal and the kind of thing on Java, my Quarkus framework. I don't need to add something new thing. It's already out of box feature. And now I'm going to time to deploy this application to Kubernetes using container zip kind of stuff. So in order to that, I'm going to add the container zip as a Quarkus extension, which you can use a Maven command line or you can use a Quarkus command line in automatic edit. And then my PubMaxM just update it with the container zip dependency here. And then go to application property. I'm going to need to add some container image compilation. So I'm going to build this one. I'm going to push this automatically to remote container registry, which is query.io. You can say whatever you want, like a Docker Hub or Google Container Registry, as long as you can access that. And here is a name kind of thing. Let me try to visit my query.io. I already have a 1.0 version. Let's try to change it 1.1. And then let me try to build again. And then it automatically packaging the job file and then containerize it. As you can see, the kicking off the G processor automatically. And I'm not gonna create the container image of my local machine because when I see the Parliament images and like a name is high performance, and I don't see that anyone. And then go to terminal again, it's already done, and then back to the container registry. And then now you can see the 1.1 version just uploaded a few seconds ago. And I don't need to use any Docker CLI and Parliament, any kind of stuff, even not using Docker file at all. And then here's my Kubernetes, like a Red Hat OpenShift based on Kubernetes, like a latest version. And I can directly import container image, something like that, version 1.1. It automatically validated, it's wrong or not, it's validated. And I'm gonna try to deploy this application right away from container registry, pulling down, and now you can see that. Here we go, and then it's already deployed. It's just one container. When it goes inside the container, it's a little bit takes more time, like a pulling container and a little bit more. That's why like a little bit, but still less than like a half a second, something like that. And I'm gonna give you one interesting one last thing here, back to the topology view. So I don't even use GraalVM right now, just JVM, but still fast. If I scale out like 100 container, for example, scale like a replica 100, and then go to here now, view 100, and now you can see the progress, how fast your 100 container is now. It's just 2 seconds, and 100 containers scale out, even JVM. If I go to GraalVM, it's just less than 1 second to scale to 100. So if you someone, maybe some seasonally workload application like a Black Friday or Christmas, and then you probably deploy 10 container, and at a time it can 10 container with 10,000 container or 100,000 containers. And what if your container takes more than like 30 minutes to scale out from 1 to 100K, and then your services is unavailable. So that's the point. I'm gonna back to the slide, and then we're gonna wrap it up. I gotta spend a little bit more time. Sorry about that.
It's great demo. Yeah, so basically we're going to work towards reducing the startup time so we don't have a fight between the typical expected startup time in Kubernetes and the typical startup time of our Java apps. We'll reduce the base images using tools like Jib. That should also work for image layering and reducing the footprint of your app. You can tune your JVM in various ways, like configuring your garbage collector for latency versus throughput, or different options like that. You can pre-initialize a lot of your classes using that class data sharing. And you can configure Kubernetes probes like your startup probe. Specifically, the startup probe is a newer probe that works well for these workloads that take a long time to warm up. Also, we have a couple more tips on enhancing container efficiency. You can set appropriate RAM and CPU limits, of course. Like I said, with the garbage collector, select your garbage collector. Optimize database access, configure your synchronization, and make sure you're using a recent version of Java that supports these the tools we mentioned.
Alrighty, so we are running on time. It's a couple of takeaways. So Java is still Kubernetes friendly, as long as you're gonna choose the right Java framework. I'm not gonna say what that is, but it's yeah, Java still matter, and Kubernetes, and you still have a good job, secure job for sure. And then I showed the demonstrate kind of thing, and then how you improve and how to put it all together into one Java framework with out of the box feature. And then, of course, Quarkus are already put together all together friendly. But I'm not going to say you always need to use Quarkus. It depends on what your expectation, what is your Kubernetes workload, what is some goal, KPI, etc. So still, there are like a GraalVM or among others, you can use your own existing Java framework, like a Spring Boot or Jakarta EE, whatever you want. So these are all kind of open source, make you give some new opportunity to improve your Java performance at all. So that's all. And then Ryan and I will stick around here. And then if you have any question, please feel free reach out to us in social media in person. And here's your feedback, please. And that's all. Thank you so much for that.
Thank you.